So to continue with our discussion of friction, let's look at the second thing that determines the force of friction. The first thing was the type of surface in contact. Well, the second thing is the normal force. Now, we know the normal force is the force that a surface exerts whenever a surface is in contact with anything else. Sometimes with friction, we can think of that as the pressure between the surfaces. So rub your hands together real quick and just use light pressure. And you'll notice that that's really easy to do. But if you press your hands together really hard, it becomes much harder. The surface didn't change in this case, but the amount of friction did change. And the reason it changed is because you're increasing the normal force between your hands. You're increasing the amount of pressure there when you're pressing harder. So there's more pressure, which means more normal force, and that increases the force of friction. One really good example of this that probably many of you have experienced before is if you drive a pickup truck, you might have noticed that the back of it slides a lot more, especially when it's wet and rainy. You have to be really careful. And the reason for that is a truck is very different than a car for a couple of reasons. First of all, most trucks are rear wheel drive, which means the actual wheels that push the vehicle are here in the back, versus many cars. Most cars are front wheel drive. And that's important because in both vehicles, the weight is more there's a lot more of the weight distributed over the front wheels because that's where the engine is. That's the heaviest part of the car. The engine is in the front. In addition to that, in the back of a truck, there's nothing. It's just the bed. There's just the body. There's a little more in the back of a car. So a car's wheels, the weight is more evenly distributed with the car than it is with the truck. With the truck, the weight is much more heavily distributed toward the front. What that means is that there is less pressure or less normal force between the surfaces on the back wheels. And since there's less normal force, it's almost like rubbing your hands together while they're lightly pressed. Less normal force, less pressure, less force of friction. But on the front, if you have a four-wheel drive truck, switching to four-wheel drive makes the front wheels catch traction as well. And that's a lot better because there's much more pressure, much more normal force between the surfaces of the front wheel of the truck. So let's do an experiment real quick just to verify this. All right, so this experiment is going to verify both of these two things that determine the force of friction. The first thing was the type of surface. I've got cork, I've got rubber, I've got sandpaper, and I'm also going to pull this thing across the table surface as well, my desk surface. It's also going to verify that the normal force changes the force of friction. So I'm going to simply pull this block of wood across these surfaces, and I've got a force meter here that's going to tell me exactly how much force it takes to pull the wood across the surface, which is also going to tell me the amount of friction on the surface, since friction is what I'm fighting. So with this one, if you look closely at the force meter, it's showing me about 1.25 newtons is what it's taking here. What do we predict with the rubber? Is it going to be more or is it going to be less? Looks like with the rubber it's slightly more, somewhere between 1.5 and 1.75, about 1.75-ish. A lot more vibration there on that one. Sandpaper. Friction on the sandpaper is very high, somewhere between 1.5 and 1.75. It's a lot harder on this one also to pull it at a constant speed. About 1.75. So these are high friction surfaces. But when I switch to the tabletop, watch what happens. Slides very easy across the tabletop. So the surface that we're on makes a big difference. We're only talking about 0.5 newtons here on the tabletop surface. Same thing would probably be true on the cardboard. Yeah, not much there. About 0.75, between 0.5, well, 0.5 newtons even right here across the cardboard. So that's what the surfaces in contact tell us. Now, the other way I can change the force of friction is to change the normal force. Easy way to do that here is to simply increase the amount of weight on top. I have a 2 Newton weight on here right now. What's going to happen if I put a 10 Newton weight on here? Took 0.5 newtons to pull it before. Let's watch what happens now. Now it's over 2. About 2.2, 2.25 newtons, something like that. It's the same block on the same surface. If I put the previous weight on there, takes much less force. And all that changed was the amount of pressure between the surfaces. The greater weight sitting on this provided greater force downward, which produces greater pressure between the block and the table. So that experiment verifies these two things that we've talked about, which is that the type of surfaces in contact as well as the amount of pressure between the surfaces, or the normal force, are the two things that determine the force of friction on an object.